Hello, doctor, professor, class, YouTube. My name is Austin, and today we're going to be getting into ICMP. We're going to talk about the anatomy of an ICMP packet, how it's used, some pretty cool attacks you can do with it before we close it out. So, if that sounds interesting to you, be sure to stick around and let's just get into it. So, as far as the anatomy of an ICMP, we can see that the header is actually only 8 bytes large. We have 1 byte for type, 1 byte for code, 2 bytes for checksum, and then 4 for the rest of the header. After that, there's a variable size data section. The first 4 bytes of the header have a fixed format, while the last 4 bytes just depend on the type or code of the ICMP packet. So ICMP messages are primarily used, in my experience, as a networking diagnostic tool. And whenever ICMP errors occur, then they are redirected back to the originating packet. For example, every device like a router forwarding an IP packet first decrements the time to live or TTL field in the IP header by 1. If the resulting TTL is 0, the packet is discarded and the ICMP time exceeded message is sent to the packet's source address. So this is useful in a number of cases. Like if you're interested in knowing if a host is alive or a computer on the network, you can send an ICMP packet to the host, and if it returns an ICMP packet, obviously it's alive. Another use case would be for networking issues. So one problem in networking is sometimes the routes are messed up, or there might be any number of issues in the actual network, and it's not actually the computer's fault that it can't talk to anything. So if an ICMP packet works and you get a response, then that nullifies a lot of the networking issues that could possibly be at play. And lastly, to go back to the host, a big issue that I've run into personally is you can send an ICMP packet to a host, but you can't receive an ICMP packet from the host. If your ICMP packets come back to you, but then you get on the other computer and their ICMP packets don't go back to them whenever you're pinging each other, that normally means that there is a firewall issue at play. One other possible scenario is if you connect to another host directly via crossover cable. If you're able to send and receive ping packets, then you can pretty reliably say that that's a firewall issue. But if both computers can ping each other, then you can at least rule out the firewall. One useful diagnostic tool that heavily uses ping is a tool called traceroute. Traceroute heavily uses ping, except traceroute's time to live is a little bit different. Traceroute sets its time to live to 1 on the first hop, and that way, as soon as the ping gets to the router decrements its time to live by 1. And at that point, its time to live is 0. So the router discards the packet quietly. And then it sends a packet back to the originating source with the ICMP time expired packet. So then traceroute gets that router's IP because that router just sent it a packet. So then traceroute will increment its time to live to 2. So then the first router will decrement the time to live, and then it will go to the second router, and then that router will decrement it to 0, and then it sends back an ICMP time expired. So now the traceroute command has the next router in line's IP. And it will continue to do this until the ICMP packet reaches its destination. So this is useful if you're trying to identify somewhere in the network that is failing, because you can see where the traffic actually stops. So there's something very important to know about traceroute. Just because the tool is not returning back IP packets does not mean that you don't have connectivity. Traceroute gets picked on because it discovers information that maybe you shouldn't have. Maybe you don't need to know every node that your packets go through. So some routers will block ping altogether, whereas other routers will block ICMP time exceeded messages. So you never receive that return ping. So while your ping got to the destination, the time exceeded message is thrown away. So that was ICMP, how it's used, some really good troubleshooting methods. It's really important that we understand how useful ICMP is to computers in general. So now what we're going to do is move on to the next portion where we demonstrate some really interesting attacks that you can do with ICMP. So the first thing we need to do is to figure out our command. So what we're going to do is we're going to just basically go down the man page and sort of make note of the different options we're going to have to specify. So what we're trying to do is to do ICMP tunneling. Basically send something through ICMP packets. So the first thing that we are going to want to look at is right here. So we've got -1 ICMP. We want to specify that the packets we send are specifically ICMP. I think we'll do a -1 to specify ICMP. We will do a /B and specify the size of our packet. We have to basically take our MTU, which we will find that in a second. We have to take our MTU minus our header size and then set the data field to that number. And then we need to specify -E for the file. And then we need to specify -U. And that should be what we need to get this done. All right, I'll see you on the other side. All right, so I've got our handy dandy website pulled up, and we've got a 20-byte IP header. We've got a 8-byte ICMP header. And then lastly, this is for some reason missing the Ethernet header, but we lastly also have to worry about a 14-byte Ethernet header. So how we are going to handle this is, let me just pull up my terminal real quick. So we know the header size. Now we need to figure out the MTU size. So now we've got our terminal pulled up, and let us do an IP adder, and we can pull up and we can see that we've got our loop back. So we want the next one down. This is the ENS33. I can tell that this is the right the right interface because I'm on the right network. So we can look at the MTU size of 1500, and that means that we can have a maximum payload size of 1500. So what we need to do is minus the header size from that, and we will get, we have a maximum header size. So this is our MTU 1500 minus the 42 header size. We can do a maximum of 1458. So that is going to set us up for what we're about to do next. So let's go ahead and use the command. So it's definitely going to be a sudo command because we are doing networking, which is more than what a regular user would need to have. But we're going to do sudo hping 3 with, we want to make sure that it's ICMP. We want to make sure that we get an end of files sent to us. That way we know when to stop sending it. We also want to specify the file that we want to send. So we're going to send that top secret .text file, which I'm not even sure if I sent that yet. So let's go ahead. We'll press enter here and it won't send. Okay, excellent. So this is the yeah, this is the top secret text that we're going to be sending. We'll just do head 10 and there we go. I must have mistyped that command. But I'm sure everybody's familiar with the top secret text. Nobody needs to tell that's watching this video. I'm watching you. And let's go ahead, complete our command. So the other thing we need to consider is how big we're going to make. Oh, wait. That's the wrong command, huh? That's not gonna work for us. How big we need to make our packets, but we're just not gonna do that. We're gonna see what happens whenever we don't take that into account. So let's go ahead. We'll send the full 1500, which we learned earlier. That's our MTU. So that is how big packets can leave our computer without fragmenting. Let's go ahead and send that. And HP missing host argument. Oh my gosh. Okay. That almost looked perfect. There's a crucial component missing. Gotta tell it where to go. And then to the host. Yeah. Okay, cool. So if we look over at our Wireshark, it is definitely freaking out. And you'll see that the it's fragmenting basically. So it's just breaking all of these packets down, basically shaving off 62 bytes. But if we can still take a look in here and we can see that it is, our text is still in there. But it's like kind of shaving off. It's sending like the last part of the packet later. So what we're gonna do now so that we can use the full power is we are going to make our packets smaller. We're going to do that by shaving off that 42 bytes of header, not 15, 1458. And let's send it and let's see what our packets are looking like. It's a perfect 1500 byte packet. Look at this first one. And if you just look at that bad boy right there, this is our top secret text in an ICMP packet. How fun! Go us. We exfiltrated that file a couple of times apparently. So yeah, that is ICMP tunneling in a nutshell. And then as one last demo, what we're going to do is we're going to see what it would take to send a packet of death. And I will send it to my computer and we are all going to hope that my computer has been patched. Okay, so let's go into man hping again and we are going to look at hping 3 and we're going to see if there is a way for us to send a very large packet. Okay, it doesn't look like there is really a built-in way to do it. Aside from, I can just make a large file, and then we can increase the MTU to the maximum packet size. So what we're gonna do is, I believe the command is something about truncate. Let's see what size or reference. Okay, so size, we will make it 65 5 35 big, and we will name it Ingodith. All right, let's take a look. We got Ping of Death, and Ping of Death is 65 5 35 big. So now let's send our hping into overdrive. All right, so we're going to keep this. We're going to increase the data to 65 535. And then we are going to send the ping of death, and let's just see how our computer handles it. 1 2 3 go. Sorry, data size must be less than or equal to 65 495. We've seen that number before. So let's go ahead and fix that. Okay, and boom. And what is our computer doing? Whoa. So many fragmentations. Oh my gosh. And it's just full of nothing. It's just a big old nothing burger. But that is the ping of death in action. All right, well, that's going to do it for the video. Thanks for sticking around. I do appreciate it. And I will see you guys next time. Bye.